We're live on 8:30 Prep. I'm Phil McCaffrey, and this is a production of my tutoring company, 3R Prep. I've got a couple of students watching these as homework assignments, so today is a continuation of last week. It's part 2 of ACT math formulas, and we're going to talk about math. I've got my producer, Damien. Say hello, Damien.
What's up?
And today, special guest, a producer under training, Teo Hadfield.
Hello.
So we've got two guys on the monitor as we're going through. Don't forget there's a live chat on here, and you can reach me at any time at phil@3rprep. So last week we stopped at exponents and roots, and we're going to pick up and just go through the things that the ACT tests all the time. The one thing I want to announce is because of the coronavirus quarantine, we're going to be doing 8:30 Prep every night, Monday through Thursday night, and I'll send this out to counselors. And so I had an old Instagram account. I started a new Instagram account, so now I have to consolidate them. But announcing tonight was we're going to have a weekly meme contest, and that is whoever sends me the funniest test prep quarantine virus meme that I post on my Instagram account, I will send you a $10 Starbucks gift card. So I already got a first winner. He gets posted next week. So Monday night's going to be meme night. We're going to post a meme. So I'll send that out to everybody that's on my email distribution list. Some people will probably be blocking me. I'll be sending out so many emails. All right, the ACT. The ACT tests exponents and roots. What's an exponent? An exponent is simply when a number is multiplied by itself. We call that an exponent. So if 2 is multiplied by itself 2 times, we say 2 squared. If 3 is multiplied by itself 3 times, we call that 3 cubed. Squared and cubed are the first 2 exponents. It is the volume of a cube, or the area of a square. So long before there was anything known as an exponent, we knew that a number times itself was the area of a square. So you never say x to the second power. You always say x squared because it's a square. You never say x cubed. You never say x to the third power. You always say x cubed. So what are the rules of exponents? Let me erase this and write some rules of exponents. There's all kinds of them. And the very first thing to know is that when you multiply the same base, you add the exponents. So x to the a times x to the b is x to the a plus b. When you divide exponents, you subtract them. X to the c divided by x to the d is x to the c minus d. A very, very important exponent to know is this negative one. So 2 to the negative 2 is equal to 1 over 2 squared. The negative sign in an exponent always means the reciprocal. It doesn't mean the negative, so be very careful on that. A negative exponent simply means the reciprocal. I don't know whoever came up with it. That's some math geek research I'm going to look at. And the other thing is a fractional exponent is equal to the square root or the root. So in this case, 4 to the 1/2 is the square root of 4. You actually never write the 2. It's just this, the square root of 4. If you use the square root symbol, it's called the radicand. It is assumed to be the square root unless you put something in it like 8 to the 1/3 equals the cube root of 8. If you're going for the cube root, you have to write the 3 in it. What are some of the things they do with exponents? Well, exponents, a squared times c squared, exponents can be distributed and factored out. So a to the a squared times c squared is equal to a times c quantity squared. Let's prove this. Let's use 2 and 3. 2 squared times 3 squared is equal to 2 times 3 quantity squared. Well, 2 squared is 4, and 3 squared is 9, and that's equal to 6 quantity squared. 4 times 9 is 36, and 6 squared is 36. So that proves to be true. Their favorite thing that they like to do in exponents is switch around bases. So 8 is equal to 2 cubed. So if you ever see anything where there are two different bases, notice if they are powers of each other. The thing that I would definitely recommend is that you learn the powers of 2. 2 to the first is 2, 2 squared is 4, 2 cubed is 8, 2 to the fourth is 16, 2 to the fifth is 32, 2 to the sixth is 64, 128, and so on. I would also know 3, 3 squared, 3 cubed, 27, 3 to the fourth, 81. 5, 5 squared, 5 cubed. They like to replace these in and out of each other, and I'll do some practice worksheets. I did a whole lesson on exponents and an exponent worksheet, and it's got the most views. I think, Damien, that's got about 150 views on the exponent worksheet. So we're not doing so bad on that one. Well, what did I do here?
Rookie move.
A rookie mistake. And it's live, right? So we can't cut it out. All right. So logarithms. I threw this in as a bonus. The ACT test logarithms. The three things that I've noticed in my studying is there's one question that is, there are three questions that are typically asked one time, but not all three of them. And that is complex numbers, the imaginary number I, logarithms, and matrices. On the last couple of tests, I've seen 2 out of the 3 of those. I've never seen a test so far with all 3 of those. So they're considered very hard concepts. So if you don't want to do logarithms, don't worry about it. I'm just going to go over them basically. I'll have a quick session on logarithms to go over. But a logarithm is simply the inverse of an exponent. So just like an exponent has a base, so does a logarithm. And 2, log base 2 of 8 is equal to 3. So the exponent is always the answer. I can't speak tonight. It's really been a long week with the COVID virus of talking to a computer screen for 6 hours. It's much different talking to a student or a class face-to-face than teaching online. So exponents have rules just like logarithms have rules just like exponents, and that multiplication is addition and division is subtraction. So I'll do a special on logarithms one night, and we'll do a bunch of ACT logarithm problems. I'm going to list on here no, but who's Dave C? No butt Pixville. Well,
Dave Cerniglia, maybe?
Is that David Cerniglia?
Who else would it be?
I hope it's not David Cerniglia. Is that you, David Cerniglia, making a comment on there? I have to watch the comments on here. So logarithms do show up. They're relatively easy. I'll do a special on logarithms. We'll do a whole one on that. What else do they ask? Number one question on both the ACT and the SAT is linear function. You are always going to see the linear function. We'll do a whole segment on systems of equations. That's coming up. And linear functions has 2 forms. This is called the slope-intercept form, where m is the slope and b is the intercept. I did linear functions on the SAT, where they like to write it backwards. The SAT is backwards. They like to write y equals b plus mx, and then ask you questions about the intercept and the slope. Slope is a very, very common tested thing. So let's just draw a coordinate plane and draw a line through it. And so here is line 1. Line 1 has the equation that the function of x is equal to 2x plus 5. The slope here is 2. That's rise over run. And the intercept is positive 5. linear functions are tested exceedingly. Out of the SAT, I've counted up of the 58 problems. They go as high as 10 or 11 linear function problems. Definitely no slope, definitely no slope-intercept form, definitely know the slope equation, definitely know everything there is about a positive and negative. This is a positive slope, a negative goes to the opposite direction. A vertical line is a line and its x is equal to some function. We'll call this 10. A horizontal line is y is equal to 3. And what's the slope formula? 100% of the time you need to know that y2 minus y1 divided by x2 minus x1 is the slope. What they often do is give you numbers and you have to plug them in. If they give you a coordinate pair, let's change colors, A and B, this is x, this is y, you substitute them in and you can solve for the problem. So there'll be a whole bunch of linear functions, 830 preps. All right, coordinate geometry. What do I want to talk about in coordinate geometry? This is the quadrants, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Absolutely tested. The two predominant things that they test on coordinate geometry is distance between 2 points and the midpoint. The distance formula is very interesting in that if you break the distance formula into the change of x and the change in y, you will notice that if we call this point x1, y1, and x2, y2, the distance formula looks like a right triangle because it is. It's measuring the length of the hypotenuse. So this point is x2 and this point is x1, and the difference, the length of this line, is x2 minus x1. This was y2 minus y1. So if we use the Pythagorean theorem, a squared plus b squared equals c squared, we get that x2 minus x1 quantity squared plus y2 minus y1 quantity squared is equal to the length, which we will call c because that's what it was on the Pythagorean theorem, is equal to c squared. So what's the distance here? C is equal to the square root of that whole thing. Pretty amazing. All right, the midpoint. The midpoint is halfway. What did I do? Use my touch screen with my palm on it. The midpoint is halfway. Midpoint, I'm actually going to toss a page in here. Midpoint simply means the average. Good thing nobody's paying me for this. Actually, I'm going to send it out to North Catholic, so my students at North Catholic have to watch this. What's the midpoint formula? x2 plus x1 over 2, comma, y2 plus y1 over 2. The midpoint is the average. In geometry, they also use words like halfway or bisect. Bisecting something halfway or cut into equal parts almost always means take the average. If it's in coordinate geometry, we're taking the average. We'll take a look at that in some future ones. Systems of equations. I want to teach this one really quickly. We're about 15 minutes into this. We like 8:30 prep to go about 25-30 minutes. In a system of equations, if it's just the equations, what they like to do is give it in standard form. And they like to ask 4 possible values. Let's draw some lines. Here's line 1. Here's line 2. Here's line 3. And then I'll show you line 4. So number 1, is there a solution to the system of equations? A solution is if they intersect. So a solution means two lines intersect. We know that two lines intersect if the slope of line 1 does not equal the slope of line 3. If the slopes are not equal, they have a solution. Giving them in standard form, we have to convert to slope-intercept form to look at the slope. So the slope of this line is y equals negative a over bx. That's the slope. That's what you have to compare. You have to solve y in terms of x. What's the second thing they like to teach? Is it perpendicular? If there is a 90-degree angle between line 1 and line 3, the slope of line 1 is equal to the opposite reciprocal of line 3. Opposite reciprocal means perpendicular. Number 3, no solution. Line 1 and line 2 have no solution because their slopes are equal, but their y-intercept are not equal. So two lines are parallel, they never touch. There's a big argument in mathematics that you never know if lines touch because you can't know infinity. That doesn't apply to the ACT and the SAT. And I've ran out of room for number 4, but let's give it another color. Let's give it green. Number 4 is infinite solutions. And infinite solutions are when one line is exactly equal to another line. And how they do this, the ACT loves this problem, and the SAT has adopted it from the ACT. And what they'll do is something like this. 2x minus 3y is equal to 8, and 6x minus 9y is equal to k. If they say these lines have infinite solutions, what is the value of k? They're the same line. The bottom line is the top line multiplied by 3. 2 times 3 is 6. 3 times negative 3 is negative 9. 3 times 8 is 24. K equals 24. System of equations in standard form 100% of the time. I'll do an entire 8:30 prep on systems of equation word problems, but I'm going to skip that tonight. Function of x. 100% of the time, the function of x is on the test. Let's use the line that I used earlier, and let's call it 2x plus 5. So if the function of x is equal to 2x plus 5, what is the function of 3? What do you do with the 3? You put it in place of the x. And we have 2 times 3 plus 5. 2 times 3 is 6, plus 5 is 11. The one thing your math teachers do that I absolutely do is use the same example all the time. For my function problem, it's always 2x plus 5 using 3 so that I don't screw it up. I always know the answer is 11, so if I'm talking to the camera and I get nervous and I screw up, I can always fall back on my long-term memory and my repetition. Losing my voice. No butt pics. Who says no butt pics? Quadratics and parabolas. A quadratic in the xy plane, they always ask something about it. And the quadratic is given in the form ax squared plus bx plus c. This is the function of x. What are the things they want to know? They love to know this point right here. And it has 4 names. This is the x-intercept. It is also called the root, the 0, or the solution when the function is equal to 0. So let's say this is the point x is equal to negative 2. And this is the point x is equal to 3. Our x-intercepts are negative 2 and positive 3. What are the factors? It's another big word in quadratics and parabolas. If the x-intercept is negative 2, the factor is x plus 2. If the x-intercept is positive 3, the factor is x minus 3. I'm going to do a whole 8:30 prep on quadratics and parabolas. We'll talk about the vertex form, how to find the line of symmetry, and the discriminant and the quadratic equation. But that's beyond the basics of tonight. Factoring and foiling. Let's use the example I just had. X plus 2 times x minus 3. To FOIL, you do the first numbers, the first, outer, inner, last. Outer, inner, last. X times x is x squared. The outer is 3x, negative 3x. The inner is 2x, and the last is negative 6. We combine like terms, and we get x squared minus x minus 6. Factoring is just taking a quadratic and going backwards. So this is factoring going in this direction, and this is foiling going in this direction. Factoring and foiling 100% of the time. What's their favorite factoring and foiling? Their favorite thing is the perfect squares as well as x squared minus y squared. And that factors into the quantity x plus y times x minus y. I've seen this more than any other quadratic, and it's called the difference of the squares. 100% of the time I've seen this. Well, 100% of the time is a little bit too much. 90% plus percent of the time I've seen the difference of the square. It's come up on the ACT and the SAT. We're at 52 minutes. Well, that's the next one plus this one. It's a matrix. I think I might skip matrix. We'll end with the equation of a circle. This is ending algebra, and we'll start next week, or tomorrow night actually, with geometry. The equation of a circle. In the xy plane, the parent function of a circle is x squared plus y squared equals the radius squared. If I move that circle out into the xy plane, and it has a center hk and a radius of r, the equation of the circle is x minus h quantity squared plus y minus k quantity squared equals the radius squared. An ellipse is very, very much like a circle, only it's a conic section. That's a really ugly ellipse. It has a center hk, and its formula is x minus h quantity squared over this length of the x-axis, a squared, plus y minus k squared over this length of the center to the outside of the ellipse, b squared, is equal to 1. And I think I might do that one as another one. I'm coming up with a lot of ideas as I do these equations. And let's end with a matrix. A matrix is an array of numbers. What they ask you to do is multiply them, add them together, and oftentimes use the discriminant, or not the determinant. I said the discriminant. That's for the quadratic. I really have lost my words tonight. So we're 54 minutes into it, which is about where I'd like to stop, 25 minutes. I'll do a special on matrices. I do have a video on matrices, so it's worth watching. And I can't talk. So thanks so much for watching 8:30 Prep. I'm Phil McCaffrey. I'll see you Tuesday night.